This is Unit 5, Cell Phones, Module 2, What Happens to Your Old Cell Phone, and Lesson 1, What Happens When You Throw Something Away. In this section, we will discuss the different types of waste that are generated, including cell phones that are classified as electronic or e-waste. What are the types of waste? While most consumers replace their cell phones every few years, each of us throws many items in the trash each day. This is referred to as municipal waste. The companies that produce cell phone components and manufacture all the other products available generate industrial waste. Preparing a home-cooked meal or working in your yard generates organic waste. Each of these types of waste has specific regulations on how it is managed and how the waste can be disposed. Municipal solid waste. This is the waste that ends up in a dumpster or a garbage can that is hauled away each week. There are many different types of materials that make up municipal solid waste. Some of the most common items are paper and food waste. Here is a pie chart that shows on average the components of municipal solid waste. And as you can see, paper and food make up the most. Then go yard trimming and plastics. Then rubber textiles, rubber leather textiles. After metals, after that wood, then glass, and then all the other stuff. Most municipal solid waste ends up in a landfill. At the landfill, the garbage trucks dump their load in a specific section of the landfill. After many trucks have added trash to this section, a large tractor with spiked wheels, like the ones you see in this video, drive over the trash several times to compact it. As sections become filled with compacted trash, dirt is added over the top, ensuring there is no open trash to attract animals. All modern sanitary landfills are lined with both plastic and hard clay soil to ensure that any leaking wastes are not able to spread into nearby groundwater aquifers. They also have pipes running throughout the landfill to gather methane gas that is produced during the breakdown of the waste by microbes. This methane can either be burned off or it can be collected and used to produce electricity. Many of these landfills requirements are the result of federal legislation that was passed in 1976 by the Resource Conservation and Recovery Act. Organic waste. This comes from plants or animals and is entirely biodegradable, which means that it will be broken down naturally over time by microbes. Some of the most common types of organic waste are food waste and yard waste. The downside to the natural breakdown of organic waste is that this process is a significant source of methane, a potent greenhouse gas. This has led some states to require that organic waste be composted or recycled and not put into a landfill, in an effort to reduce the amount of greenhouse gas, aka methane, produced and to save landfill space for municipal wastes. Household hazardous wastes. These are wastes that are hazardous to human health and can contaminate the environment. Thus, they cannot be disposed of in a landfill. Other examples of municipal hazardous wastes are unused pharmaceutical drugs, cleaning products, and car batteries. Special rules for hazardous waste disposal have been created. There are three main ways that a hazardous material can be properly disposed of. Incineration, which is burning the waste at very high temperatures. Part of the regulations on burning hazardous chemicals is ensuring that the products from the combustion must be captured to prevent any harmful chemicals from being emitted into the atmosphere. Pyrolysis, incubating the waste at high temperatures to speed up its breakdown. This is different from burning the waste as it is usually done in the absence of oxygen, and it is quite expensive. Isolated landfill, a specifically designed landfill for hazardous materials. These landfills have even more stringent monitoring and barrier requirements to ensure that the hazardous materials are well contained. Industrial waste. Many industrial processes generate waste considered hazardous or non-hazardous. Some examples of non-hazardous waste include construction materials. Some examples of hazardous industrial waste include radioactive waste, such as those generated at a nuclear power plant, biomedical waste produced by hospitals and research laboratories, flammable waste, or materials that can be harmful or explosive. Some non-hazardous industrial waste can only be disposed of in separate landfills from municipal solid waste. A more difficult challenge is the proper removal and disposal of hazardous industrial waste. Prior to the 1970s, asbestos was commonly used as insulation due to its fire retardant properties. During the renovation or demolition of an old building, asbestos dust creates many jagged microscopic particles. When inhaled, the particles can cause damage to the lungs, and with longer exposures can even result in a form of lung cancer called mesothelioma. In some states, industrial waste must be disposed of in specific landfills that are separate from those used for municipal solid wastes. Another example is that of the Love Canal in New York. In the 1940s and 1950s, the Hooker Chemical Company owned the Love Canal in New York, and it used it to dump hazardous chemical waste. The company simply filled metal drums with waste materials, put them in the ground, and covered them with dirt. The company later sold this land to the city of Niagara Falls for $1, which built a community with around 100 homes and a school. Years later, many women in the area experienced miscarriages or delivered babies with birth defects. Pools of chemical waste appeared in people's yards or seeped into their basements. In 1978, most of the families in the region were moved. Superfund legislation passed shortly after and was used to help pay the nearly $300 million cleanup cost for the area. The Love Canal site is one of the hundreds of Superfund sites across the country. Now we're going to go back to e-waste. So what happens to old electronic devices? In addition to cell phones, which are replaced every 2 or 3 years, many other electronics have short lifespans. Rarely do electronic devices last more than 10 years, resulting in a lot of electronic or e-waste. Despite the valuable metals and potentially hazardous chemicals found in e-waste, only around 15% is recycled, meaning that most ends up in landfills. In 2010, a federal task force was established to study how the U.S. could improve its strategy on electronic stewardship. The task force released a report the following year which suggested that the recycling of e-waste needed to be increased, along with reducing the export of e-waste to other countries. Often, one of the ways that countries deal with their glut of old electronics is to simply send them to a developing country that is not equipped to properly process or recycle the items, yet again ending up in landfills or polluting streams, rivers, forests, open fields. Another e-waste directive is the WEEE directive, the Waste Electronic and Electronic Equipment. This is what the European Union passes, which was several directives related to managing the amount of e-waste collectively. The most recent goal is that 85% of e-waste would be recycled by 2016. Most of the burden for these directives fall on the manufacturers and distributors of electronics. The directive requires them to establish an infrastructure to allow consumers to return used electronics free of charge. That's all for this lesson. Now we're going to move on to lesson 2. How can we manage what is thrown away? In this lesson, we will review the methods that are used to manage waste, along with some changes in products and packaging that have the potential to greatly reduce the amount of waste that ends up in landfills each year. In the US, how much trash gets thrown away? In the US, about 30% of our trash is recycled or composted, with another 12% incinerated. Most of the remaining waste, roughly half, ends up in landfills. Since 1960, the total amount of waste generated each year has tripled. The amount of waste generated per person rose until around 2000, but since then, the amount has actually decreased. This is due to improved waste management, with more waste being recycled or composted. Another interesting trend is that in 1960, almost all of the waste generated went to a landfill, whereas today, the amount is only around 50%. Here you can see the hierarchy of waste management strategies from most preferred to least preferred in terms of environmental standpoint. The EPA has established these guidelines for waste management with a number of ways that waste can be managed, starting from those that are most preferred to least preferred. What can we do with our garbage? You may have heard of reduce, reuse, recycle. Each of these seek to decrease the amount of waste that must be managed to begin with. If that cannot be done, utilizing waste as an energy source is another way to repurpose these materials. Failing these strategies, disposal is a final option. Disposal. For many years, the sites of garbage disposal were appropriately named dumps, and dumps had two major problems. Dumps attracted many animals to the area to eat the uncovered trash, and there was no barrier between the soil and the garbage, meaning that any liquid wastes could penetrate the soil and possibly contaminate local water supplies. Modern sanitary landfills have the ability to store tremendous amounts of compacted garbage, with the average size around 600 acres. Once the landfill space is used up, the dirt-covered hills can be reused for another purpose, such as solar farm, natural area, or ski hill. Some potential downsides are that they are expensive to build and operate, they take up a large amount of land, and produce a significant amount of methane from the digestion of organic materials. Due to these challenges, this is one of the least preferred waste management options. Landfills are generally located from large population centers. This is due to the space needed of a landfill and also the NIMBY effect, which stands for Not in My Backyard. NIMBY. Not in My Backyard effect contributes to higher waste removal costs as trucks have to drive further to dump the collected trash. The elevation and land slope are also important to consider in a landfill site, as sites at lower elevations or with steep slopes may be more susceptible to flooding or runoff during heavy rain. Ideal landfill locations would be on ground level without any steep slopes nearby. A buildup of methane can lead to this home being completely destroyed. On a cold morning in March 1986, the pilot light on the furnace turned on in a home in the town of Loso, England. During the night, methane had traveled through old mining tunnels under a nearby landfill and spread into the basement of the home. The ignition of the pilot light caused a massive explosion, leveling the home and badly injuring the three people inside. Now we have these kind of machines that are meant to absorb all the methane and transport it elsewhere. Energy recovery. Other than taking trash to a landfill, it is possible to burn it using the heat that is recovered to generate electricity, a process referred to as energy recovery. Municipal solid waste is lifted into a burn chamber where the waste is combusted and turned into ash. The heat generated from this process turns water into steam, spinning a turbine and producing electricity. Burning 1 ton of trash can generate about $20 to $30 in revenue. There are currently 75 energy recovery facilities on the eastern coast of the US, in some of the most densely populated areas. The incinerated trash produces electricity using around 12% of all generating municipal solid waste. Other countries have even higher rates of energy recovery by combustion, with both Japan and Sweden burning more than 50% of their municipal solid waste for energy. Some of the benefits of energy recovery are that the only waste that goes into a landfill is the ash left over. Some challenges are the initial cost of a facility, which can be hundreds of millions of dollars. When these types of facilities were first established, their emissions were not controlled, and they subsequently contributed to air pollution. Following the passage of the Clean Air Act in the 1970s for the US, these facilities must now have pollution control equipment installed to ensure their emissions are not polluting the air. Organic waste, animal, and plant materials must be broken down by microbes to produce methane using an anaerobic digester, as seen here, to produce biogas. The digester consists of an enclosed space with a high temperature and low amount of oxygen to encourage anaerobic bacteria to break down the organic materials. After 20 to 30 days, the breakdown of the organic materials results in the production of biogas, a mixture of gases but mainly methane and carbon dioxide. Biogas can be burned to produce electricity, or it can be processed further into bioplastics or biofuels. After the anaerobic digestion, the remaining material is called digestate. This can be added to fields as organic fertilizer, used as animal bedding, or turned into materials such as biodegradable pots for plants. Recycling and composting. Composting can be considered nature's version of recycling, a similar process to anaerobic digestion but with oxygen. It also uses organic waste, such as food scraps or plant material, and relies on microbes naturally present in the environment to digest or break down the organic wastes. Some of the benefits of composting are that organic waste can be converted into useful materials like compost for gardens. Some of the challenges are that it can take a very long time, up to a year, for some materials to compost. Currently, we compost where I work and I run that, so employees are allowed to bring in the food scraps from home. No meats, no cheeses, no dairy products, no bones, just like vegetables and fruits and even yard waste, and it can be composted. Source reduction and reuse. The easiest and most environmentally friendly way to reduce waste is to have less source material to start with. There has been a large push by many companies to reduce the amount of packaging materials and also make them more sustainable. One example is reusable drink cups. Starbucks, one of the largest global coffee chains, estimates that it uses more than 19 million disposable cups and lids each day at its stores around the world. In March 2022, Starbucks announced that by the end of 2023, customers will be able to get their order in their own personal reusable cup, which it hopes will dramatically cut the number of disposable cups that are thrown away. Many schools and businesses are now providing students or employees with reusable bottles to fill up with water instead of using a disposable plastic bottle of water, which is most often discarded. Returnable bottles and deposits. In 1960, 95% of soda sold in the US was in returnable glass bottles. By 1998, that had dropped to less than 0.5%, with plastics and aluminum cans accounting for more than 99% of all soda packaging. The use of returnable bottles allowed for the same packaging to be used many times, with it just needing to be cleaned in between uses. It is estimated that a glass bottle can be reused around 40 times, and even then, the glass is able to be recycled instead of being discarded in a landfill. Some companies, such as Oberweis Dairy, still continue the tradition of delivering milk to homes in returnable glass bottles. Coca-Cola has announced that by 2030, their goal is to sell 25% of their products in returnable and reusable glass bottles. Zero waste or refill shops. Zero waste shops allow you to repurchase things like soaps and cleaning products with reusable bottles. When you use up the product, just bring back the container or bottle you get refilled. Many online retailers can also ship back refills to you. Changes to product packaging. Another way to reduce waste is to find ways to reduce packaging for materials or make them materials biodegradable. Amazon.com is one of the largest users of packaging and shipping materials, and they have implemented many changes in the last few years to reduce the amount of packaging material they use. For example, they now have some products in frustration-free packaging in which they encourage sellers to use packaging that is easy to open, contains less material, and is easier to reuse or recycle. They also are using algorithms and machine learning to help ensure that they have the most efficiently packed items in each package that they send. Amazon claims that These and other changes have helped to reduce their per package materials weight by 38% since 2015. More and more packaging is also being made with biodegradable materials to ensure that they break down quickly once in a landfill. Some of the most common items that are switching to biodegradable materials are drinking straws, cups, and food packaging. Unfortunately, these new biodegradable items currently cost more than the equivalent plastic item, which is slowing the transition to more environmentally friendly materials. 8 states, starting with California, have enacted bans on single use plastic bags. In some cases, plastic bags are allowed if they are biodegradable, or shoppers are charged a fee to purchase a single use bag. Many large cities, including Chicago, Boston, and New York, also have bans on the use of plastic bags. Similar laws are in effect in many other countries around the world. In 2021, the European Union enacted a ban on single use plastics, including plastic silverware, bottles, and bags. That's all for this lesson. Now we are moving on to lesson 3. Is recycling worth it? In this lesson, we will review the methods that are used to manage waste, along with some changes in packaging and products that have the potential to greatly reduce the amount of waste that ends up in landfills each year. Is recycling worth it? Recycling is defined as taking waste and processing it to make new materials. While there were short periods of interest in recycling in the US, for example, during World War II, it was the environmental movement of the 1970s that really increased the prevalence of recycling. By 1980, there were more than 200 curbside recycling programs in place, collecting materials like paper and glass, which could be converted to new materials. During the last 40 years, many states have enacted laws requiring the sorting of recyclable materials or prohibiting items that could be recycled from going to a landfill. The nationwide recycling rate has slowly risen from around 10% in 1985 to over 30% today. The US still lags behind many other countries in the amount of materials that are recycled. Germany and Austria have the highest rates of recycling in the world at over 60%. Here you can see the most commonly recycled items. Please pause this and take detailed notes. I am not going to go into depth, but it is steel, aluminum, glass, plastics, paper, and cardboard. However, only about 15% of cell phone components are recycled, with the rest being solely discarded. What materials in your cell phone can be recycled? There are robust recycling programs for many industrial materials, especially asphalt and concrete. Concrete manufacturers have found that taking up old concrete and crushing it up can produce a base material very similar to what is normally used, avoiding the labor and energy costs with sourcing new rock. Asphalt can be recycled in a similar process, where the top layer of material from a road surface can be removed and crushed, and the aggregate can be used to make new asphalt. Recycling as a percentage of the total generated waste. Recycling rates have increased over the past 38 years, but are still relatively low for glass and plastics. There are many reasons why the recycling rates for some materials remain low. There is a lack of financial incentive for people to recycle. Lead acid batteries have a recycling rate of nearly 100%, and this is mainly attributed to the fact that there is a core charge that is refunded when you return the used battery. The requirements for materials to be used in recycling can often lead to many recyclables being rejected due to contamination. For example, most plastic and glass containers need to be rinsed, and paper products cannot be contaminated with food or other materials. The EPA estimates the contamination rate for recyclables is about 25%. Number 3, much of the recycling market is dependent on the cost savings of using recycled goods compared to making new ones. What products can be made with recycled materials? Here you can see from that first list of what can be recycled, what can be made from those same materials new. So please pause and read this. Here is a great example of something that is made from recycled materials. A bench. HDPE plastics are commonly recycled into durable weather-resistant boards, which are used to make outdoor benches. Metals are usually desirable to recycle, as they can be 100% recycled in an unlimited number of times. The price of base materials also influences cycling. For example, plastics are made from oil, which can change in value. Glass is made from silica and sand. And with a cheaper base material, there can be less demand for recycled glass. Another factor is whether there is a local market for recycled materials. In the past, much of the recycled goods in the US were shipped to China, where they were turned into new materials. If a producer could use recycled goods in North America, that could make the transportation cost much cheaper and therefore increase the demand for recycled goods. As new products use higher amounts of recycled goods, there is increased market for recycled materials. Numerous companies today have already increased the amount of post-consumer recycled materials in their products. For example, General Mills has pledged that by 2030, all of their packaging will be recyclable or reusable, and Kellogg's has stated that by 2025, all of their packaging will be sustainable, meaning either compostable, recyclable, or reusable. Enzyme-based recycling. In some ways, recycling is a victim of its own success. The curbside pickup of recyclable has led to a tremendous supply by which sometimes is not met by the demand for these materials. So some of the more difficult items to recycle is plastic due to many different types of plastics. This has led to many plastic items having very low rates of recycling, like plastic bags, which only 5% are recycled. One way to break down is that using enzymes to break down all the different plastics down to their same base components. A French company has modified an enzyme from bacteria to be able to break down PET plastics into their basic components. When tested, no differences have been found between using this recycled material and regular base components in the formation of new plastics. Using recycled materials in new ways. Many people are working on finding new ways to use recycled goods, which will hopefully create more of a demand for these items. One new approach is that's being tested is using ground up glass to make concrete. Up to 30% of the Portland cement can be recycled by your glass powder. Your cell phone and almost all the other things you use each day contain materials that can be recycled. The question is whether there is enough demand for these recycled materials to make it worth the time and effort required to remove, extract, and process the materials for making new goods. And that is the last part of Module 2. I will see you guys in the next one.